Tonight, we're going to embark on a journey into the unseen, the unknown, and the utterly mysterious. We're going to talk about something that makes up most of the universe, yet remains invisible to us. Something that doesn't emit light, doesn't reflect it, and doesn't interact with it in any way. Something that, despite its elusiveness, holds the very fabric of the cosmos together. Tonight, we're diving into the enigmatic world of dark matter. So close your eyes, let your mind wander, and let's explore the invisible threads that weave the universe into the tapestry we see and don't see today. The cosmic mystery. Imagine looking up at the night sky. The stars, the galaxies, the vast expanse of space. It's breathtaking, isn't it? But here's the thing. What you're seeing is only a tiny fraction of what's actually out there. In fact, the stars, planets, and galaxies we can observe make up just about 5% of the universe. The rest, well, that's where things get interesting. About 27% of the universe is made up of something we call dark matter. It's not like the matter we're familiar with. It doesn't shine, it doesn't glow, and it doesn't interact with light at all. It's completely invisible, and yet we know it's there. How? Because of its gravitational pull. The invisible hand. Let's take a step back and think about gravity. You know how the Earth orbits the Sun or how the Moon orbits the Earth? That's because of gravity, the force that pulls objects with mass toward each other. Now, imagine a galaxy. Galaxies are vast collections of stars, gas, and dust, all held together by gravity. But here's the strange part. When scientists calculated how much gravity a galaxy should have based on the visible matter, the stars and gas, they found that it wasn't nearly enough to hold the galaxy together. The stars on the outer edges of galaxies were moving far too quickly to be explained by the gravity of the visible matter alone. It was as if there was an invisible hand, gently but firmly holding the galaxy together. That invisible hand, that's dark matter. The first clues. The story of dark matter begins in the 1930s with a Swiss astronomer named Fritz Zwicky. Zwicky was studying a cluster of galaxies called the Coma Cluster. He noticed that the galaxies in the cluster were moving much faster than they should have been, given the amount of visible matter in the cluster. He proposed that there must be some unseen matter, what he called Dunkelmaterei, or dark matter, providing the extra gravitational pull needed to keep the cluster together. At the time, Zwicky's idea was met with skepticism, but as the decades passed, more and more evidence began to pile up. In the 1970s, astronomer Vera Rubin studied the rotation curves of galaxies and found the same thing. The outer regions of galaxies were rotating too quickly to be explained by visible matter alone. Rubin's work provided some of the strongest evidence yet for the existence of dark matter. What could it be? So if dark matter is real, what is it made of? That's one of the biggest questions in modern physics. We know it's not made of atoms because atoms interact with light and dark matter doesn't. It's not made of the particles we're familiar with, like protons, neutrons, or electrons. So what is it? One leading theory is that dark matter is made up of particles that we haven't discovered yet, particles that don't interact with light or ordinary matter except through gravity. These hypothetical particles are called WIMPs, which stands for weakly interacting massive particles. WIMPs are thought to be heavy, slow-moving particles that rarely interact with anything, which is why they've been so hard to detect. But WIMPs aren't the only possibility. Some scientists have proposed that dark matter could be made up of tiny black holes that formed in the early universe. Others have suggested that it could be made of particles called axions, which are incredibly light and interact very weakly with ordinary matter. The truth is, we don't know yet, but the search for dark matter is one of the most exciting areas of research in physics today. The cosmic web. Now, let's zoom out a bit. Dark matter isn't just important for holding galaxies together. It plays a crucial role in the large-scale structure of the universe. Imagine the universe as a vast cosmic web. The threads of this web are made up of dark matter, and the galaxies are like glittering beads strung along those threads. This cosmic web formed in the early universe, just after the Big Bang. Tiny fluctuations in the density of matter, most of which was dark matter, created regions that were slightly denser than others. Over billions of years, gravity pulled more and more matter into these dense regions, eventually forming the galaxies and galaxy clusters we see today. Without dark matter, the universe would look very different. There would be no galaxies, no stars, no planets, just a diffuse, featureless expanse of gas. Dark matter is the scaffolding upon which the visible universe is built. The search continues. So, how do we find something we can't see? That's the challenge scientists face in the search for dark matter. One approach is to look for the effects of dark matter on visible matter. For example, dark matter can bend light from distant galaxies, a phenomenon known as gravitational lensing. By studying these distortions, scientists can map the distribution of dark matter in the universe. Another approach is to try to detect dark matter particles directly. Experiments like the Large Underground Xenon Lux experiment and the Cryogenic Dark Matter Search, CDMS, are designed to detect the rare interactions between dark matter particles and ordinary matter. So far, these experiments haven't found anything definitive, but the search continues. There's also the possibility that dark matter could be produced in particle accelerators like the Large Hadron Collider, LHC. By smashing particles together at incredibly high speeds, scientists hope to create dark matter particles and study their properties. The bigger picture. Dark matter isn't just a scientific curiosity, it's a fundamental part of our universe. Understanding it could help us answer some of the biggest questions in physics. What is the universe made of? How did it evolve? And what is its ultimate fate? But dark matter is also a reminder of how much we still have to learn. The universe is full of mysteries, and dark matter is one of the most profound. It's a humbling thought. The stuff we can see, the stars and galaxies, the planets and people, is just the tip of the cosmic iceberg. Most of the universe is hidden from us, waiting to be discovered. As we drift off into the realm of sleep, let's take a moment to marvel at the universe we live in. A universe filled with wonders we can see, and even more wonders we can't. A universe where the invisible threads of dark matter hold galaxies together, where the cosmic web stretches across billions of light years, and where the mysteries of the cosmos invite us to explore, to question, and to dream. Thank you for joining me on this journey into the invisible universe. I hope it's given you a sense of awe, a touch of curiosity, and perhaps a little bit of peace as you drift off to sleep. Until next time, this is Curiosity Naps, wishing you a restful night under the stars.